Welcome to another episode of Plaas TV. Today's focus is on silage. Environmentally sustainable silage practices is critical to agriculture, and its importance has given rise to Plaas Media's annual Santam Agriculture National Silage Competition. The competition aims to provide all entrants with a detailed, individualized report on the quality of the silage they entered. Labworld, a division of Philafrica Foods, has been contracted to conduct sample testing. Plaas TV recently visited Dr Elrisa Taljaard and her team of experts at Labworld to explain how the testing of the samples are conducted. But first, the latest agricultural news.
ABE Biotech. Fermentasie is gelyk aan prestasie.
In vandag se nuus, Suid-Afrika se oudste landboumaatskappy NWK het die afgelope finansiële jaar sy grootste wins nog behaal. Hierdie wins is bykans 60% hoër as die van die vorige finansiële jaar. NWK het in die finansiële jaar wat op 30 April 2022 geëindig het, 'n voorbelaste wins van R346 miljoen verdien. Die belaste wins vir die jaar is R267 miljoen. Dit is R100 miljoen meer as die vorige jaar. Volgens Heinrich Krüger, voorsitter van NWK se direksie, kan die besonderse prestasie grootliks toegeskryf word aan gunstige weerstoestande en die suksesvolle implementering van die maatskappy se sogenaamde omdraai-strategie. According to data from the Milk Producers Organization, the total cumulative monthly supply of milk for the first 5 months of the year is 4.5% less than in the same period in 2021. This is also 9% lower than the same period in 2020. The total milk supply in the first 5 months of 2022 is at its lowest levels compared to the previous 5 years. NPO economist Bertus van Heerden says the demand for unprocessed milk has been suppressed since 2019. And a series of Russian missile strikes have recently hit the critical Ukrainian port of Odessa. According to Wandile Sihlobo of Agbiz, the Russia-Ukraine grain deal signed early in July was a positive step in addressing global food insecurity. In this deal, Russia agreed not to attack grain vessels in the Black Sea region, a step which could restore the grain trade. Sihlobo says this attack will cause grain traders and merchants to be reluctant to enter this risky zone, which ultimately defeats the deal. The deal itself was significant as Ukraine has roughly 22 million tons of grain in silos that is unable to reach export markets. That's today's news, but stay with us.
Hello everyone, thank you for visiting Labworld today. Please come in and we can show you how our process works.
Awesome. Okay, so that's done. Now that we've done that, registering your sample, let's take it to the NRR room. You can join me.
This is our NRR room, and this is where we take the spectra of the sample, as well as where we start with the moisture analysis. So Manko is going to show you how the sample is being scanned initially on a curtain, and then we are going to show you how the moisture is taken and then later on how the final product is scanned.
Okay, so as we receive the sample, we first take it obviously out of the packet. We mix it all up just to have everything all together, and then what we do is that we split it into 4 quarters so that when we do scan, we scan each part of the sample to get a representation of the whole sample. So this is our NRR pattern. This is where we scan our silages. We have different setups for the NRR. So for the scanning, we'll go on the analysis tab. We have calibrations for all of the products that we do receive in the lab. For this is our maize silage. So I'm going to go on the maize silage calibration. This is our maize silage calibration. This is the previous results from the scan. So when we start with the scan, what we're going to do is we're going to click on the Analyze tab, and then it will give us this pop-up screen. This is where we register the sample onto the NRR. We have this barcode scanner scans this barcode, which automatically generates the sample ID there, and then we add our customer with the one sample that's the quarter sample that's been placed into the sample packet. We put on the NRR, and then we click on Analyze. Then we register the sample onto the NRR, and then the first sample, quarter of the sample has been scanned, so we continue with the next one. And in the meantime, I'll prep for the different quarter. Okay, so now all 4 quarters of the sample that we had split have been scanned. The NRR will generate results based off the scans, and then we have different calibrations that have been built into the product. It analyzes for dry matter, moisture, protein, fat, and the other parameters. And then from here, we then move on to the moisture disk. So this is where we analyze for our moisture. We have our balance over here. We use these packets to have the sample in so that it goes into the oven. They have already been pre-weighed. So what we do from here is we take our packet, put it over there, and then because now it's been pre-weighed, I don't have to write it down again. Then I weigh for moisture 2, which will go in for 24 hours. I write down my weight. And then we are done with our moisture. From here on, it goes on to the 50-degree oven, and then there's the 105-degree, which will go in for 3 hours. Then from here on, before we take it into the oven, we register the sample for CVAS. So after the weights have been taken down for the moistures that we do on the sample, we go on to CVAS, which is a application that we use to further analyze the sample. So when it comes to the registration part of it, we go on Add a Sample, and then we fill in our details. It will generate a number for us that we use for traceability purposes. Okay. And then for the registration parts on the farm name, we put in Plaas Media. And then on the quick feed type tab, we add corn silage because it is a maize silage. Go on in there. And then on the description, we use what we receive as the customer's ID on the sample, which is P23. Before we can submit the sample, we do make sure that every detail that we get from here matches exactly with the details that we're going to put on to the sample. So we will then, this lab ID that we get from the CVAS application, we write down on the sample packet. And then we take a picture of this number, the sample in its packet and in the tray. We then take a picture of these two together. And then click on submit over there. And then this is a tab just to show if we can continue with the next one. So for now, just go and cancel. And then we upload this picture that we have taken now so that when the report is generated, the picture is within the one report. Okay, for the sample in the packet crucible number 1, it's going in for moisture 2 in the 50-degree oven, and then the one with crucible number 2 is going to go in for moisture 3, which is then going to the 105 degrees for 3 hours. So this is our oven that's set at 105 degrees. This is the way we'll put the one sample that's going in for 3 hours. So we put it in there. And then we set a timer for 3 hours. Then when it rings, I know that it's time to take it out. And then this now one sample goes into the 50-degree oven. This is our other moisture oven, which is set at 50 degrees, the sample is then gonna go in for 24 hours. There, let me close it. So once the sample has went in for 24-hour moisture analysis, the same time that it went in, we're gonna go there and write it down on the clipboard so that the following day it goes out the same time.
We use 2 different moistures because we treat the sample exactly the way that CVAS want them to be treated, because their calibrations are done specifically in mind how it's been dried, how it's been milled. So we have 2 different moistures. The one moisture that went into this oven is a sample that's actually going to be milled. So that's dried at a very low temperature, so we're not losing any of our volatiles. The sample that we put in the 105-degree oven is dried for a shorter time, but those 2 moistures have to match one another so that we know that this sample that is dried at a lower temperature is dried sufficiently enough that that is the correct moisture for the sample. So that is our control sample, and this is the sample that we're actually going to do the analysis on.
This is our 50 degrees oven. That's where we put our moisture 3 for drying. So what I'm going to do now, I'm going to take out the dried sample before we're going to weigh them. No, before we're going to weigh them and mill them. Okay. Now, this is our 2 dried sample. Now we're gonna go to our moisture lab to wait for them to cool and weigh them and put them in their packaging before we're going to mill them. Now, what happened here is that the sample they are cooled down now. What we're going to do, we're going to weigh them, and then whatever the value we get it, we write it here next to the wet samples value. Okay, now this is our first sample, which is the value is 33.753, and then I'm going to write it next to the sample number. Okay, and then now I'm going to write it here. Okay, now this is our bag. Now I'm going to put our sample back to its own bag. Okay. Okay. Now this is our second sample. Then we weigh it back again, and then we're going to write the value here. Then they are ready for milling now.
We have two different types of milling that we do. For the SIVA samples, as I've explained, we use a specific moisture, specific procedure for the SIVA samples. So they are milled on the FOS instrument according to specifications, and all the other samples we mill on the hammer mill, so that we can have them 2 millimeter size, so that we can do the ash on that sample afterwards.
We have two types of milling machines for our Plaas Media samples. The hammer machine, we mill the normal moisture tree samples, and then the FOS machine, we only mill in the SIVA sample. So before we continue, we have to first put our PPE on. First of all, what we normally do, we have to make sure that our equipment is clean. We open it and clean it and set it up and make sure that everything is 100% and works smooth. And then what we do, we just mill our sample. But now, the other thing, we have to put it a little bit, not too much, because that's what I did. That's what I did. You don't have to feed it too much. You have to feed it slowly, like a baby, slowly. You don't have to put it too much. And then what's happened, we mill the whole sample. Then when the sample is done, you wait for a little bit so that the final sample can go to our little cups, as you can see. And then when we're done everything, we just put it back to our normal bags. That's, as you can see, it's a different, it's a bit finer. We mill everything together so that we can get the right result here. That's why we mill the whole samples.
Communique exists to serve feed and food producers.
Vir al die Plaas TV kykers, julle wil weet oor die rand. En ek gaan julle sê hoekom, want al die boere is besig om te oes. En teen julle vriend van my, hy is besig om te oes, maar hy het slegte nuus gehad. Een van sy stroopers het sommer in die land vasgeval. En hy sê vir my, Frans, dis 'n massiewe werk om hom uit te kry. Maar hy wou weet ook van die rand, en dit is baie beslis so. Ons doen 'n weeklikse skrywe oor die rand, want dit bepaal baie van die boere se suksesverhale. En die rand het so bietjie versterk die afgelope tydjie, en nou wil ek vir boere sê, terwyl hierdie rand bo R16.63 bly, is die verswakking nog in plek. Dan moet hy moet onder 16.63 kom op 'n Vrydag sluit om my opgewonde te maak dat hy verder kan versterk, want wat sien ek hier? Ek sien 'n pragtige stygende wig. 'n Stygende wig is gewoonlik 'n formasie wat vir jou sê dat die rand kan verder versterk. So onder 16.63 en hy gaan na 16.05, maar ek wil amper sê, ek weet nie of hy veel laer gaan na 16.05 nie. Oorsaaklike rede, want ons het 'n baie sterk lyn hier by 15.51, is die top 40, die rand se 40 week bewegende gemiddelde lê baie naby aan hierdie vlak. Ek wonder of ek gou die tyd gaan kry om hom kan in te trek vir die boere. Ek glo daar nie, ek hoop nou net nie, ek hardloop uit dit nie. Daar is hy. Kom ons kyk gou of ons hom daar kan intrek vir die boere, dan kan hulle net sien, daar is die 40 week, daar is hy, en dan maak ek hom gou 'n bietjie vir julle duideliker, en ek hoop julle kan hom dan sien. Daar's hy presies daar op hy vlak. Terwyl die rand bo daardie vlak van 1549, 1551 is die verswakkende tendens ongelukkig van die rand in plek. Dankie, besoek gerus ons webtuiste www.franseklerk.com vir meer inligting en as jy 'n daaglikse opinie oor die rand het, skakel in by ons daaglikse Prinsipview.
We're here now at where we're doing the ash. The ash is basically an indication of what your mineral content is, if there's any soil or any non-organic material in your sample. So Evelyn is doing our ashes to determine how much of the inorganic material is in the samples.
My name is Evelyn Mwachi. I'm responsible for doing ash in my department. And then I'm going to show you how do I do my ashes. First thing first, I make sure how many samples do I ash. And then I'm taking my crucibles over my cabinet there, nicely cleaned. I put them on my table and then I write them, I number them accordingly. And then as I'm looking at my samples, I take my crucible, my ash sheet, and then I write every details of my ashes that I'm going to do. And then I make sure they correspond with my crucibles. And then I'm going to start showing you how do I do my ash. I have to write there who performed the analysis that day is me, Evelyn, and the date that I've performed the analysis. And then I write down all the numbers and the moisture, the ashes numbers on the side. First thing, before I start weighing my samples, I have to take my control. My control is the sample that I have to determine that we're still within a spec of the analysis. Then I will take my crucible. My first one, it has to correspond with my control. I look at the number, if it corresponds with my crucible. So it has to be number 17. It corresponds with my crucible here. And then I weigh my crucible first. I put it in there. And then I close for the wind to go out of my scale. And then I check the way. I'm gonna write this way, right here next to it. First, that is my sample, and it corresponds with the number I've written here. It's the same thing. Then I check, I write that weight over there. And then I take my sample. I have to mix it nicely. I have to weigh 1 gram.
Okay, this is the pH station. So pH is important for silage because the better it's in silage, the lower the pH is. pH we do on the fresh sample because during drying some of the volatiles, the ammonia might get lost. So we do it on the fresh sample, and Yamkela is going to show you exactly how it's been done.
So I'm just going to show you how we do it. First of all, to measure pH, we use our pH meter. So we are having our pH buffers. So these we use them as standards. We use them to correct our machine before we run because we want to make sure that our instrument is reading the correct results. So what we're going to do, we are going to take our sample that we're having. So as part of our sample storage, we want to make sure that at all times our samples are sealed to make sure that we don't lose any moisture or any volatile acids in the sample. So we are just going to weigh about 5 grams of the sample into this beaker. We use the tweezer just to make sure that we don't contaminate our sample as we work. That's our 5 grams. Then when we're done with the sample, we'll just put it here. Okay. Just to rinse my tweezer off, as I had mentioned that we try by all means not to contaminate our sample. So after that, we are just going to add about 100 mils of deionized water. Okay. So the reason why we're adding deionized water into our silage sample, first of all, it is to soak the sample with the water so that we can be able to extract the pH, or to have the sample to be homogenized so that we can be able to test. So this is my sample that I have. The next step that we are going to do is to mix the sample, which is I already have one already in my stirrer that is already mixing, and then I also have one that I had prepared earlier which has already been stirred. So we stir for about 10 minutes and then we let our sample just to sit, and so that everything can settle at the bottom. And then this is my pH meter, as I had said earlier on, with our pH electrode. So the next thing that we're going to do now, we are going to measure the pH, our pH electrode. So this is just going to hold and show you guys. As you can see, then we're going to just give it some time, which is we normally give it about 20 seconds to about a minute, so that we have everything settled nicely. So already our instrument has already measured the pH, and it is at about 3.7, that is on the pH scale. So when we are done, I'm just going to rinse out, put my sample aside, and this is my beaker that I'm going to rinse my electrode into. Okay, our electrode now is nice and ready for the next sample. It has been rinsed. Just going to put this. So what we do, we're just going to record our results on our pH sheet, which is 3.70. Thank you. So basically this is how we do and test our pH.
I'm now finished weighing my samples. I'm going to take them to the furnace. This is my furnace. I'm going to open it up now, bring it in and pack my samples nicely in there. I begin with number 1. I have to put number 1 there at the back, put them in row of 5. And then I close my furnace before I go and put it on. And then I come in and put it on here, and then I check. Then I see that my furnace is too high. I have to reduce it to the right amount of 500. Now my samples are ready to be taken out of the furnace. I've left them to cool, and then I open the furnace now. I take my samples out. I use my tongue to take my samples out. First I take the first one, carry it nicely. The second one. Now my samples are ready. You can see how they have been etched. All right, I'm taking them down now to be way back. I leave my sample to cool at room temperature, and then I'm now ready to weigh them back. Then I'm taking them in and close. Put them there. My results are ready.
Okay, so after the sample has been completed on moisture and the way it's been taken down, it's been milled, we then come back to this force NRR and we scan for the SIVAs. The number that we used for the registration will be the number that we used to register the sample scans here, which will then be used for the report. So I'm just gonna put this into the small cup. So, and then straighten it out with this leveler thing, and then put it in there, and then close. It will then scan, and then after scan, the result will come out, and then our RSL will then generate the report. I mean, that'll be the end of the sample.
And this is the final process. Everyone bring the results, or they have logged the results already in the LIMS system. From the LIMS system, we generate a report. We basically have 2 reports that we generate, one for the wet chemistry and one for the SIVAs. The SIVAs report look like this. It have all the results on the dry matter, which was done in the ovens, the moisture and the dry matter being written down, and then the entire scan as per group of samples that's been analyzed, either maize silage or the mixed silage. And this then we put in one huge Excel spreadsheet and we send it off to Robin and he does the magic with it.
Thank you, Plaas TV.
BKB, die betroubare tuiste van landbou. BKB, the trusted home of agriculture. Elanco, we are driven by our vision of food and companionship enriching life.